Okay, we're going to be talking about lesson 8.3, which is trigonometry. So first of all, trigonometry means triangle measure. So trig is triangle, metry is referring to measure. Trigonometry is used a lot in pre-calculus and beyond. So the purpose of trig is that it will allow us to find sides and angles in triangles for which we don't have another way of solving for them. So we will be doing right triangle trig, but you'll also spend about a quarter of pre-calculus doing trigonometry on non-right triangles. So the definition for a trigonometric ratio, a ratio that compares the lengths of two sides of a right triangle. So in this right triangle, so first of all, let's focus on angle X right now. In relation to angle X, we have two different legs. Now we know the hypotenuse is the side that's across from the right angle, so this is your hypotenuse. In relation to angle X, we have one side that's across the triangle, that's the opposite leg, and then we have a leg that's adjacent to angle X, which is not the hypotenuse because we're looking for a leg, and that's what we'll call the adjacent. So the hypotenuse already has a name, that's the hypotenuse. The two legs are either opposite or adjacent. So in relation to angle X, across from capital X, you'll see little x, that's common notation. And then across from capital Y, you'll see little y. And then across from capital Z angle, you'll see little z, the length of its side opposite. Okay, so three different trig ratios. This is called the sine of x. When you abbreviate that, it looks like this, but you still say sine. You don't say sin, you say the sine of x. Sine is defined to be the length of the opposite leg over the hypotenuse, okay? Opposite over hypotenuse. So in relation to angle X, the opposite is your little x, your hypotenuse is your little z. Okay, so the sine of angle X would be little x over little z. And cosine. Cosine of angle X is abbreviated like COS, and you still say that as cosine X, is defined as the adjacent leg divided by the hypotenuse leg. So adjacent over hypotenuse. The adjacent to angle X is little y, and the hypotenuse is z. So it'll be little y over z. Okay, on a problem that we're going to be looking at, there will be numbers there. So it might be like 1/3 or 2/5. Okay. The tangent of x is abbreviated as tan x, and again, you still read that as a tangent of x. The leg opposite divided by the leg adjacent. So opposite over adjacent is tangent. So opposite x over adjacent y. Opposite x over adjacent y. Okay, and those are simply the definitions for sine, cosine, and tangent. Now, in any right triangle that, for example, has a 35-degree angle, if you were to do, so this has a 35-degree angle, so does this one. If you were to do the sine of 35 degrees, for example, the sine is the opposite divided by the hypotenuse. And in the other triangle, the sine of 35 would also be the opposite divided by the hypotenuse. Now, these two triangles are similar. Why are they similar? Well, they're similar by angle, because they're right triangles and they both have a 35-degree angle. So when you compare the opposite over the hypotenuse, in both of those triangles, it'll be the same ratio because the triangles are similar. Okay, so the ratio over here would simplify down to the same value as what this would be or what it would simplify to. So trig is all based on similar right triangles. Okay, there's a mnemonic device that is helpful for you to know to be able to do these problems, and it's SOH, CAH, TOA. Okay, we say that as SOHCAHTOA. So SOHCAHTOA means sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Okay, so that's a way to help you remember the definitions. And if you would want to write them, you can also write vertically. If you'd rather write it as sine is opposite over hypotenuse. Okay, whatever is going to make sense to you to remember it. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. You'll use this all the time when you're doing trigonometry. So, even as a teacher, I still am thinking of that when I'm ready to set up problems. Okay, so we're asked to find the sine of A, the cosine of A, and the tangent of A. All right, angle A is up here. In relation to angle A, I'm going to list what the sides are. Now, of course, across from the right angle is going to be our hypotenuse. In relation to angle A, the opposite side is our 12, and the adjacent is our 9. Okay, so again, there's two legs, the opposite and the adjacent. Okay, so the sine of angle A. Sine is defined to be opposite over hypotenuse. In relation to angle A, opposite is 12, hypotenuse is 15. We can take a 3 out of both of those, 4/5. Okay, cosine of A. Cosine is adjacent over hypotenuse. Okay, so for angle A, adjacent is 9, hypotenuse is 15. Take out a 3, 3/5. And then tangent of angle A is opposite over adjacent. So it's going to be 12 over 9. Take out a 3, 4/3. Okay, now we're going to switch to the other angle here. So looking at sine of angle B. For angle B, I'm going to switch now to the other angle. So if this is angle B, then in relation to angle B, our hypotenuse, of course, is still our hypotenuse. But our opposite and our adjacent change, because across from angle B is 9. That's our opposite now. And then 12 is our adjacent. So when you switch to the other acute angle in the right triangle, the opposite and adjacent will switch. Again, the hypotenuse doesn't change because the hypotenuse is the longest side across from the right angle, so it's never going to change. Okay, so for sine, sine for angle B is opposite over hypotenuse. In relation to angle B, opposite is 9, hypotenuse is 15. 9 over 15, take out a 3, 3/5. Okay, cosine is adjacent over hypotenuse. 12 over 15. Cosine is adjacent over hypotenuse. 12 over 15. Divide out a 3, 4/5. Okay, and then tangent of angle B is opposite over adjacent, 9 over 12. Take out a 3, 3 over 4. Now I want you to notice something. Angle A and angle B would be complementary to each other because in this right triangle, the right angle takes up 90, so the two that are left over there would have to also add to 90. So those two angles are complements. I want you to notice how the answers here compared to the answers over here. Okay, you might notice that these two are the same. These two are the same. And then how are those guys related to each other? So up here, the sine of angle A is the same as the cosine of angle B. And the sine of angle B is the same as the cosine of angle A. For the tangents are reciprocals, right? So the sine of angle A is 4/5. That's the same as the cosine of angle B, 4/5. The cosine of angle A is 3/5. That's the same as the sine of angle B, 3/5. And again, the reason that makes sense is because the hypotenuse didn't change, but our opposite and our adjacent from angle A switch when you jump to angle B. So the denominator stayed the same, but the numerator's changed. Okay, and then for tangent, they're still opposite over adjacent. However, you're talking about angle A here and angle B here. So that means that your opposite and adjacent switched, which again is going to have the effect of flipping over the tangents. So, for example, the sine of an angle is the same as the cosine of the angle's complement. The sine of an angle is the same as the cosine of the angle's complement. That means that if you were to do like the sine of 70 degrees, the sine of 70 would be the same as the cosine of the complement, which is 20. Or the cosine of 5 degrees would be the same as the sine of the complement, which is 85 degrees. Okay, it's just something that's helpful to notice. All right, we're going to use a calculator now. So if you have a scientific calculator or a graphing calculator, you want to grab that. You can pause this video if you got to go find it. But it's best for you to use a calculator that would be a handheld that you don't have to use an app for. So if you do not have a handheld calculator, you might want to consider getting an app that looks like a TI calculator. This is called Graph and Calc. Oops. Graph and Calc 83, if you like the way this one works. Okay, but whether you're using a scientific calculator or a graphing calculator, you need to make sure that you are in degree mode. It is super, super, super important that you're in degree mode. And I want you to be typing these in your calculator as I go through them because you want to make sure that your calculator is in the right mode. Now, on a scientific calculator, in a graphing calculator, right here, you have that mode button. It's in the second row. Let me do that a little bit better. It's in the second row beside the second function key, the second one over underneath graph to the right of the second, the yellow second, orange second key. Okay, when you hit mode, it will bring up the options of radians or degrees. You can see that down here. Now you're going to also have that option for you on a mode button. I think it's the third row down. You want to make sure that degree is darkened. So use the arrows left or right and make sure degree is darkened and then do second mode to quit out. So I'm in degrees. If you're using a scientific calculator, there will be in your display, there will be maybe something that says D, or it might say DEG. If it says R, or if it says RAD, that's bad. Okay, you want to change it to degree mode. So usually there's some kind of mode button or some way to change your calculator setting. There will be, you just have to find it. Okay. All right, so just to make sure we know what's going on, we're going to do sine of 30 equals, and that'd be 0.5. Cosine 30. And we're rounding to 4 decimal places, so that would be 0.8660. Tangent 30. 0.5774. Okay, sine of 60. 0.8660. Cosine of 60. Now, I already knew that was 0.5. How did I know that? So let's pause for a second. Remember what we just talked about. This is 30 degrees and 60 degrees. That means that the sine of 30 is the same as the cosine of 60, and the cosine of 30 is the same as the sine of 60. So these should be the same. Okay, tangent 60 is about 1.7321. Now remember, these are supposed to be reciprocals of each other. So if you wanted to double check that, we could do 1 divided by 0.5774 is about 1.7320. It'd be off a little bit because they're rounding, but They should be reciprocals. Okay, now the rest of this lesson is going to be talking about how to solve triangles. That means if I give you a triangle like this, it's a right triangle. I want you to be able to figure out all the missing angles and all the missing sides. Okay, that's everything else that is going to be in this lesson. Okay, so we're going to write down, before we start here, we're going to write down so, ha, toa. Sine is opposite of hypotenuse, cosine is adjacent of hypotenuse, tangent's opposite over adjacent. Okay, for some reason my little degree symbol down there ended up jumping down. I'm not really sure why that happened, but that should be, let me make that black. That should be 36 degrees there. Okay, so easiest thing to find would be Z. Now, we know that all of these angles add up to 180 degrees, but we also know if we take away that 90, the leftovers have to be 90. So to find that Z, I'm just going to do 90 minus 36. So 90 minus 36 is 54. Okay, now to find the side lengths, I'm going to use the 36 degrees that I already knew. And it doesn't matter if you find X first or if you find Y first, but we have to use this 8 because we can only have one variable in the problem. It doesn't matter which one you find first. I'm going to go ahead and do X. Now let's label in relation to the 36-degree angle. This is your opposite, that's your hypotenuse, and then this is your adjacent. Now again, it's opposite leg, adjacent leg, and hypotenuse is the one that's across from the right angle. Okay, so if I use 36, X, and 8, well, let's see, 36 degrees, move that adjacent out of the way here, 36 degrees, and I'm using opposite, and 36 I'm using opposite, and I'm using hypotenuse. So which one of those uses opposite and hypotenuse? Well, that would be opposite and hypotenuse would be sine. Okay, so I'm going to do the sine of 36 degrees is equal to the opposite, which is X, over the hypotenuse, which is 8. Okay, I'm using sine because I want X in my equation. So I have to use 36 degrees and 8, those are the numbers I know. And I'm using X, so I want opposite and hypotenuse, which is sine. Okay, now this is just an algebra problem. Sine of 36 is a number, so to get X alone, we're just going to multiply both sides to get rid of that 8 on the right side. Gone. That's what we're typing in the calculator. 8 sine 36. And again, you want to make sure you type that in your calculator so that you know that the value that you're getting is correct. So that should be approximately, let me see what I told you around to. Nearest 10. Okay, so nearest 10th, about 4.7. Now that was a length, and I did not tell you if it was meters or feet or whatever, so it's just 4.7. Okay, so we've got Z is 54, we've got X is 4.7. Now we're going to find Y. So this time, notice that I'm using the 36, the Y, and the 8. Well, Y and 8 are adjacent to hypotenuse. That's cosine. So it'll be cosine. Let me move this out of the way here a little bit. The cosine of 36 degrees is the adjacent, which is Y, over the hypotenuse, which is 8. We're going to multiply both sides by 8. Cancel. Type that in our calculator. 8 cosine 36, about 6.5. Okay, that would be the end of that problem. However, I want to make sure you understand you could use the Pythagorean theorem on this problem to finish once you have 2 of the side lengths. So as a side note, you would not have to do this if you've already solved, but in case you would prefer, you can always do 4.7 is your x, that squared, plus y squared is equal to 8 squared. Okay, 64 minus 4.7 squared, 41.91. Square root of that answer is about 6.5. That approximately is what that means. It's the two tildes. So instead of an equal sign, it's two squigglies, and that means approximately. So if you prefer, you could have used this method and not done trigonometry twice. Okay, I'm going to pause there and make this a new video to be continued.